Hello, I wish you a very good morning. I would like to welcome you to our today's Factory of the Future with FDM webinar with Michael Anton as speaker. This is Edith Gutmann speaking at the moment. I am the EMEA training specialist and will be the host and coordinating the questions and the raised hands. Before I'm passing on now to Michael, I would like to just give you some general information on the handling. You have noticed already that you are in listen-only mode at the moment, which is no problem with regard to questions because since we will have breaks after every chapter. So Michael Anton will make breaks after every chapter. So you have the possibility to type in your question and then I will read it aloud. Michael can answer it, and we will also have at the very end of the presentation a Q&A session where we can unmute you, and you have to use then the raise hand function. We will unmute you. You can place your question. Furthermore, I also want to tell you that we are recording this webinar as usually. So if you need to jump off earlier or you have colleagues who are not able to attend, you can feel free to give them the information that they can find the recorded webinar later on Train Me on 3D. Now, it's only left to say, wish you an interesting webinar and pass on to our speaker. Welcome, Michael.
Good morning, everybody, to this more or less wonderful day. Today it's the second webinar this year. And this webinar is talking about FDM, the news of FDM. So you see our 3 points we want to raise today. The first one is the new Stratasys F900, third generation, now with nylon 12 carbon filled. Section 2 is our new PEC material. We call it Antero 800 NA. And in section 3, we discuss the ABS Plus refill kit. And as Edith mentioned, we will have a Q&A section at the end of the complete webinar. And I'm doing a break between each section, so you have the possibility to ask your questions and give us your notes. So let's start with the first theme. This is the new Stratasys F900 with FDM nylon 12. This is launched in Q2, so it means now. This new system, its base is a third generation. It's based on the 4100 MC. You all hopefully know. And this system is made to minimize your production risk. Yeah, you know, if you're doing a production, you have to run with deadlines. You have a go-to-market. You have your product specifications, your quality issues. You have decisions to make. You have to run the costs. It's all about data and data flow, of course. And this machine is Industry 4.0 ready. So in the next couple of minutes, we will highlight a little bit these points. At first, I want to introduce the new Stratasys F900. In the outer picture, there's no that much changes, of course. This F900 is the most proven and reliable manufacturing 3D production system on the market today. And as I told you before, it's developed to reducing your manufacturing risks of parts. The printer itself is the most versatile, reliable, and accurate and proven system we have on the market today. It's a 3D manufacturing system with 14 industrial-grade materials on board, with a wide range of print resolutions, from 0.13 to 0.5 millimeters. We have 4 or 5 different tips on board. It's the Stratasys largest FDM print area commercially available at the moment. Yeah, this must add. It's all about data driven. It's connectivity. It's all for connectivity and visibility. We have a live data analytics. This system is MT Connect ready and is accessible, informative, and easy to read your job reports. One couple of points more about the risk reducing features. We have here a confidential flag. You can lock your CMB files. You have a better moisture management and monitoring. There's a dew point monitor and a powerful airflow dryer on board. And you have an internal camera what can monitor your actual production. So the next slide is talking about the largest print envelope with the greatest variety of advanced FDM materials. So we talk about large parts, we talk about industrial grade materials, we talk about production parts with a consistent accuracy. So some high features to talk about the available materials. As usual, we have all the ABS materials on board. M30, M30i, DEST7, ASA, polycarbonate, PC ABS, the whole class of nylons now with nylon 6, nylon 12, and carbon filled nylon 12. We have PPSF, ST130, and both Ultim materials are running on this system. You have the build size. That's why this machine is 900 by 600 by 900 millimeters. And we have 5 different layer thicknesses, starting with 0.13 to 0.178, 254, 33, and with the G40, you can run 0.5 millimeter layers here to be very, very fast with your materials. Finally, this Stratasys F900 3D system is the most powerful FDM system available and delivering a remarkable production agility and high return on investment. This product produces a demanding functional prototypes, production parts, jigs, fixtures, factory tooling with an unmatched accuracy, repeatability, and predictability. This system is designed to meet the demanding needs of your manufacturing. So, of course, we have some customer stories here from customers. They already use this machine. And the first one is the team Penske. It's an IndyCar racing team. And they use this F900 for their end-use parts. Andrew Miller, the Penske composite design engineer, gave some summarize, and over the past 6 months, we have significantly reduced our time and cost to get new components directly to the racetrack, particularly composite components. So Team Penske is an American racing team in the IndyCar series. The challenge here is that the current fueling line used during the pit stops is too heavy, and is slowing down the refueling time. The solution here is using the FDM nylon 12 carbon filled to having a 3D manufactured refueling tool, with the benefits of the main one is the reduced weight of this handle and of the whole refueling kit. They are able to refuel cars with greater speed and ease of use, and they have reduced tools needed to service the car, because this is, you see it here in the upper picture, this is all made in one part. So the next one is Trike, with functional prototyping, jigs, fixtures, and production part. Also, we have the voice here from Ashley Guy, the manager of Trikes. He told the excellent strength and stiffness to weight ratio of the FDM nylon 12 CF material is a game changer for us. It means we can prototype almost every part of the product in under 2 weeks, whereas in the past it could take over 2 months. So the challenge for Trike is reducing costs on small run production parts, and producing strong enough functional prototypes. Solution also here is FDM nylon 12 carbon filled with the following benefits. They cut the production time from 2 months in 2 weeks, reducing the costs by 8 to 10 times, able to produce final production parts with nylon 12, functional prototypes able to withstand their rigorous testing, and the nylon 12 carbon filled is throughout the design and the production process, and also for prototyping, jigs and fixtures, and for production parts. So they cover their whole part production circle with our carbon-filled material. So the next one is a brake. Edith, can you ask for questions, please, before we starting into the new pack material?
So we do not have question at the moment. If you would like to type in your question also, as said, you can do it in between. Then we will read them aloud after each chapter. So you don't need to wait with your question until the very end. But so far we don't have no written question. Thank you.
Okay. So we go ahead with the new pack-based material. The material is called Antero 800 NA. So at first, some information about the naming. This material is pack-based, so this is not pure pack. We are having an information about a bit more information later in this one. Antero 800 NA. Antero is the name of a North American mountain range. The 800 is just a number. SKU stands for stock keeping unit. So this is just a differentiate number, a differential number, to differentiate this material from the others coming in the future. And this A stands for natural color. With this material, we are having a special support material. The support to this Antero 800 NA is the SUP 8000B, and this is a breakaway support. Okay, the most benefits, or what we see is of this new pack-based material is the aerospace and automotive industries, because they are looking for ways to reduce weight and cost for their production and move from metal to plastic wherever possible, because plastic is mostly lighter. So you see here a picture of, I guess, aluminium or steel parts, and they can be made also wherever possible in the new plastic material. The pack-based material is all about chemical resistance. So the major point here is to withstand chemicals such as fuel or hydraulic fluids and other aggressive fluids. And some other words, what is the pack? Pack normally comes in different shapes. So this is a casted material in blocks or in other pre-produced shapes. And this is the options the manufacturer have, and they can mill and turn these preform shapes, and we give them the opportunity now to print the parts directly and have no waste anymore with this production. Yeah, the customer challenges using standard pack. The critical parts where pack is required are usually customer parts needed in low volumes with a challenge to produce this part. Limitations at first, as I told you, due to the pack stock shapes and sizes are available in this world. This is because you need to traditional manufacturers parts. You have limited design options because this need to be machined with CNC milling, turning, and so on. And this still incur lengthy your production time. So that's why we having the possibility now to produce parts, specific parts, directly with the 450. This is mainly for producers of aerospace and other high performance vehicles who need this pack material, the parts that are chemical and temperature resistant, strong with an ultra low outgassing and an exceptional wear properties that of course require a good strength. And the benefits here, the 3D printing with Antero 800 and A produces complex and low volume parts faster, cheaper, and lighter than using a traditional method by CNC, the available casted preform shapes. Some words to the properties. The pack-based FDM thermoplastic is or gives us a high chemical resistance with a high temperature resistance and an ultra low outgassing. We have very good wear resistant properties. It's mainly in the aerospace, automotive, motorsports, and other manufacturing industries. It's available in a natural color and it's using its own support. Top applications is conductors, ductings, housings, clips, brackets, prototypes for functional testing, manufacturing aids, jigs and fixtures, and tooling. For instance, for the clean room, because of this ultra low outgassing. So we have here some comparisons to the Ultim 1010 and the Ultim 9085. You see in the tensile strength, tensile modulus, we have higher values here. The elongation at break is a bit higher than for the Ultim 9085. This gives us a high strength. The temperature, the melting point of the material is at 310 degrees, and the glass transition TG is at 150 degrees. So we have very good outgassing also better outgassing than 9085, and this gives us the NASA specification they need when these parts are used in the open space. Yeah, some more words to the industries using the PEG-based materials in the aerospace, where parts exposed to cleaning chemicals, fuels, hydraulic fluids under high temperatures. Typical parts are clips, brackets, radomes, ducting, and high requirement tooling. In the space industry, for ground support equipment, during the assembly, for testing, and for flight operation parts, where are required high temp stability and the low outgassing as well. In the industrial manufacturing, mainly in the high-end manufacturing with exposure to chemicals and high temperatures. So here we talk about custom tooling parts, clean room compatibility, and jigs and fix test parts for electronic production. Another industry is oil and gas, where parts exposed to hydrocarbons. Here we talk about custom fixtures, housings, and electrical connectors, and then the last one is the area of the motorsports. Also here we have an exposure to fuels and other aggressive chemicals. We can use this material under the hood, where fuel components and high temp brake cooling ductings are needed. And mainly for tooling applications, of course. So also here we have some use cases. The first one, the parts used in the gray space behind the skins of the fuselage and of wings, where weight optimized support brackets are needed and may be exposed to jet fuel or hydraulic fluids. The challenge is to reduce the weight of the aircraft, reduce the cost on low volume but complex parts, where fast iteration and design verifications are standard, to reduce the large supply chain delays. And of course, you have design limited freedom due to manufacturing and material properties. The solution here use FDM Antero 800 NA with a weight saving on the aircraft, what directly comes back in a reduction of costs. It gives you a much higher supply chain flexibility for parts. The chemical resistance or chemically resistant plastic allows a metal replacement and weight reduction. The part consolidation due to design freedom reduces fasteners, failure points at interfaces, what gives us an additional weight reduction. And of course, we have a quickly iterate and save time, what directly comes back also in a cost reduction. Another one is the aircraft support bracket. Here we're talking about the huge aircraft companies, Boeing, Airbus, Lockheed, Gulfstream. The application here is support brackets. The use case, parts used in the gray space, we also already discussed this. And you have here, if you download the presentation later, you have here all the commercial, the situations where this material gives you a huge advantage in the design and manufacturing area, mainly reducing the weight and the costs for low volume parts, gives you a better iteration, a faster iteration of design, with all these benefits we have discussed already. The next use case is the aircraft custom duct. Also here, we have parts in the so-called gray space behind the skins or in the wings of an aircraft, where complex and weight optimized ducting is needed, and may be exposed to, again, jet fuel or other aggressive liquids. The challenge here is that the ducts or the ducting comes very late in the design, yeah, you have to create a space, and you have routing challenges for your channels and ducts. Yeah, the design iterations and changes can delay because of a large supply chain, and due to manufacturing and material limitations, you have design restrictions. Also here, yeah, by using the new pack material, you are much more flexible in your design, and this will have an effect, a positive effect on the costs and your time and the weight. So you don't pay penalties because of the normal production parts, because you're free in the design. With the new Antero 800 allows you to fabrication of complex duct shapes without weight. This will without the weight or cost penalties. It means you can use free-form customized parts which you cannot produce on the traditional way by CNC or with additional fasteners, what is adding some weight. This is the major point here. The next one again is a deeper dive into aircraft custom ducting, and we already discussed this case, so I want to directly go over to the next one. What jumps us in the space where fiber optic routing components are needed. The use case here, you see, it's a routing guide used to route fiber optic cables on a satellite. The challenge, reducing weight, is very critical. A very short production time. Here we have the outgassing point in the foreground because of the vacuum in the space. And not to forget, we have a launch table on the schedule, and we have to be ready on time. The solution also here, of course, FDM Antero 800 NA with design flexibility will reduce your cost, time, and the weight penalties. The material allows and fabrication of complex duct shapes without any penalties in weight and cost, and you are able to do fast iterations on design changes without asking for your supply chain. Also here we have a deep dive into this case, and the next now we're doing the next Q&A, because the next is the ABS Plus refill kit. So Edith, please ask for questions.
We have one question. We have two questions from Mike. Is the support material dissolvable in water and safe to discharge to wastewater line?
No, this is a breakaway support. At the moment, the sub 9000 or 8000 B is a breakaway support, so no caustic soda will work.
Okay. And the second question is, will Antero be available for the 380 machine?
No, not at the moment. Yeah, it comes at first to the 450.
Okay, and then we have a raised hand. So shall we use the unmute function even though we normally make this?
Yep,
Yeah,
please, of course. Yeah,
Okay.
yeah, do
So
it. Yeah.
Vicky, I will unmute you. Hello, can you hear us? Hello, Vicky. So maybe this was by mistake. I will mute you back again. Okay, then we can continue. I don't have no further questions.
Okay.
Thank you.
So let's go ahead with the new ABS Plus refill kit. This is also launched in Q2, so this is already available. The major point, you save 25% with the ABS Plus refill kit. This kit includes a refill spool of material, including the chip on the dimension or Fortus 250 MC printers. So, yeah, this costs 25% less than the current dimension of Fortus 250 ABS cartridge prices. Here in the picture, you see the kit themselves. More details. It comes only in ivory at the moment. In June, additional refill kits will be offered in black and also for the support material. But at the moment, this refill kit is only available in the ivory color. A used dimension of Fortus 250 MC model or support material cartridge, can be any, is needed to use the kit. We do not offer or sell empty dimension cartridges because you have to open your canister, and you will see this later in the movie, and install the spool and the chip, close all together, and then you can use it. So you have self-assembly items with an instruction, the responsibility for the correct assembly, the cartridge handling, and necessary tools falls up in the end user. Yeah, means you have to take care about that the kit is working fine when you installed the new spool. Okay, here you see this ABS Plus refill kit guide. It is 3 pages and explain step by step how to install a new spool. And as next, I'm showing the movie. Okay, give me a second. I'm showing the movie. So, stop. So what you see here is how to open a used spool, a used canister, with a cutter, and remove some screws. Yeah. You see the empty spool and the drying packs. You can remove these dry packs. Then you open the new cartridge, the new spool. It comes with a foil bag, yeah, to keep it dry. So you have new silica dry pads, the new chip, and the new cartridge. So just open the spool. So then please add the dry packs back in these corners to keep the material as dry as possible. Replace the chip. And close the cartridge. And you're ready. So I close the video, come back to the next page, and now we're having a Q&A session. At first, let me read and answer this ones. This is mainly about the pack. If we say that Antero 800 is based on pack, what exactly does it mean? It is a blend, or what other materials are blended in, and Antero is a peak pack copolymer that is specifically formulated to maximize the material attributes in the FDM process. So that means our pack based is a peak pack blend. Peak and pack are both materials of the pike family, but yeah, this is a blend we're using today. Next question. At the moment, we show use cases focused on the automotive and aircraft industry because of the improved chemical resistance versus Ultim 9085. How do we see the possibility to use Antero also within the medical industry for instruments or implants or some other uses? The answer here, our raw material supplier currently will not support the use of the material in medical, especially implants. We are at the moment negotiating with them the ability for certain skin contact applications, but this will need a little bit of time. I guess this is maybe next year. What about the suitable support? Also a general question regarding Ultim materials. At the moment, currently, we do not have a suitable support that will work with our high temperature materials such as Ultim or Antero. And the last one, do we are working on a pure peak or pack materials without intermixtures? The answer here, there's no work on a pure peak or pack for FDM at this time. So with this, we are at the end of the webinar for today, and now we can open the channels for your question, please.
Thank you, Michael. So, taking a first look to the raised hands, I see no. Please feel free to use a small and functionality, then I can unmute you in case that something is still unclear or you want to have some more details. Looks like we
So
have
if
all
there
the
are
informations. Yeah.
no questions, yeah, then I can offer you to send us an email with your questions or needs, whatever it is, to my email. It's michael.anton@stratasys.com. Yeah, we are. Please do say many thanks for your attendance today, and see you hopefully for the next webinar in June when we talk about PolyJet.
Thank you.
Many thanks.
Thank you very much, Michael, and also thank you to everybody for your interest and also some questions. And we'd like to just mention that we will have a very short 5 questions feedback form, which we would kindly ask you to fill out when we close the webinar. It will pop up when we are closing the webinar. Thank you very much in advance. I wish you a very good day ahead, a good weekend, sunny one hopefully, and take care. Goodbye.
Thank you very much. Bye.
Goodbye.